Okay, you learned about matrices. A matrix. What's a little tiny piece, a number in a matrix called? Maybe you didn't get that far. There's a name for it. An element. A little number in the matrix is called an element. And let's say that it's got 4 elements. You get that there's actually multiple ways you could make the matrix if it's got 4 elements. Do you get that it could be like this? That's a matrix. Do you get that the 4 elements could actually be written like this, though, also? Or they could be written this way. Those all have 4 elements in them, but they're different. Why? Because if I said how many rows and how many columns the matrix had, that would be an important thing. I know you'll learn that. Would you please write these 3 matrices when there's multiple matrices, call it matrices. Would you please write these 3 matrices, and then underneath them, this is not correct, but would you write a row by column for each of them? Remember, rows go this way. Columns hold up buildings, and they go up and down. I have a problem with this. It's not easy for me. It's just dumb. I know I have a 50-50 chance, but I don't do enough matrix problems to just be like, oh yeah, I instantly know it's, well, in this case I do, because I know there's 2 by 2, and I can't really mess it up. But on the next one, it takes me a minute to think, is that 4 by 1 or 1 by 4? I know it's one of the two. This one's 2 by 2. Raise your hand if you had that one right. Okay, good. Everybody should have right. But is this a 1 by 4 or a 4 by 1? All right. Now, the way I ask myself is this: how many columns does it have? Because they're easy. They hold up buildings. That's a column that holds up the building. There's only 1 column, and so then it must be this one. It's 4 by 1. How many of you your gut feeling was right on that, and you had the 4 by 1? Okay, good. Then this last one must be a 1 by 4. Now here's a strange question. Could I multiply? Actually, I'm just going to leave that back. Put it back up there. Could I multiply? I'm going to call this matrix A by matrix B. Would that be a legal multiply? Nope. Can't do it. How about if these are A and B, this is C. Could I multiply B by C? Not looking at A. I know it doesn't look like those two could get along, but they can. It's a really tall matrix and a really short matrix. That'd be sort of like, let's say you had a professional basketball player who's like 7 feet tall, and then there is a really short gymnast who's like 4 feet tall, and they have a baby. What's it going to look like? Will it just be average? Well, one thing, if you actually want to know this, you'd need to look at their grandparents. Not the parents of the baby, but the grandparents of the baby. Because if you go back to the grandparents and you include them in your equation, think about this. What if that short person actually had kind of tallish parents? That can happen. If you go back and look at the grandparents, do you get how that kind of cancels out the person who is short, and then the grandparents affects it too? All right, so moral of the story, there is an equation for finding out what you're going to look like when you're all done growing. Some of you might be done growing. But Michael Jordan, by your age, still had 9 more inches to grow. He grew 9 more inches from whatever age you are right now, because he grew those during college. Okay, so some of you guys might not be close to done growing. And others of you might be totally done right now. Like, in fact, you were done last year, and you're never going to get any taller. So how do you know? You look at not just your parents, you need to know your grandparents' heights as well. If anybody wants to bring that in, I'll tell you the formula that would tell how tall you're going to be based on your grandparents and your parents. All right. Well, what would this look like if you put it with that and you multiplied them? Well, I can tell you this. Since these two match, the inside ones, if those match, then the result will be a 1 by 1 matrix. 1 by 1, that's just one number. Yes. When you multiply these two matrices, you get just one number. All right. We'll come back to one like that, and I'll do it for you later. But one more thing. What if I reversed these and I put it the other way? Did you know that if you have a matrix and you, let's say this one, and another matrix, I'm going to call this A and this B, -3, 8. If I multiply these two out this way, I will get a totally different answer than if I reverse them and multiply B times A. If I just write them the other way, you get a different answer. Isn't that strange? That should seem strange to you because you're used to like 3 times 8 is 24 and 8 times 3 is still 24. Doesn't matter if you reverse them. With matrices, it matters. If you write them backwards, you get different answers. Okay, so what is the answer? Well, how do you multiply two matrices? That's the new thing for today. So this one is a 2 by 2 and a 2 by 2, and of course, big surprise, this matches up so they work, and it's a 2 by 2 matrix at the end. I'd like you to copy down this problem. I'm going to show you how to multiply matrices out. Now, I've been doing a day each unit where I kind of tell you the whole chapter all at once. I don't usually do it the first day, but usually by like the second day, I'm trying to tell you the big picture, like everything you have to know. And it gets like kids go, oh my gosh, that's so much stuff, and they don't often leave with it mastered. Of course, you're only on like day 2. But overall, I think it worked pretty well this chapter. I don't know, how many of you have already checked your grades? Raise your hand if you have. All right, and some of you haven't checked, but the grades in here, if I were to read through them, would be like 95, 95, 95, 95, 85, 95, 95, 95. So, yeah, I'd say it's working. Let's keep doing that. So I'm going to try to go really far today and try to teach you like almost everything you need to know about matrices. And it might feel like too much right now, but then we can go back and fill in the little pieces, like fix the little problems that you might have with it. All right, so I like to put Easter eggs where my answers are going to be. This one's got 4 answers, and I'm going to put little circles there. And then I name those locations. I don't have to name them every time, but when you're new at this, it's probably pretty smart to just do all 4 of them. It doesn't take very long. I'm not going to name them like Stripey and Pokey, and I remember my daughter used to name fish as I would catch them, throw them in the bucket. And of course, the names were always based on what they did. You know, if they were like really sharp and pokey, she'd call this one Pokey, and that one Stripey. I'm going to call this R1C1. Take a wild guess why. Row 1, column 1. And I'm going to call this one, and you need to do this, please. Just catch up to me and give a name to each spot. And let's think this through. Is that row 2 or is that column 2? It's because it's not row 2, column 2, that's for sure. What's that one? Row 1, column 2. Yep. Yes, sir? There are other ways to name them, yes. And I'm going to stick with this way just because this is the way I taught my other class. And you're absolutely right that there's other ways to do it. Did she teach you that other way yesterday or not? She did. Oh, well, maybe I should do it that way. I'm this far. I'm going to finish it with this problem, but then I'll do the other problem the other way. Okay? All right. So this is going to be row 2, column 1, and this last one's going to be row 2, column 2. Are you saying before this would have been, what would the name of that one have been yesterday? How did she teach it? A22, like little sub numbers like that? Would you choose a little letter A or a big letter A? Little. All right. That makes sense to me. All right. I can do it that way too. And this would have been A22, and this would have been A21, and this would have been A11, and this would have been A12. That works. The reason I like my way, yes, it does have one extra letter in it, but it tells you which was the row and which is the column. You know what I mean? So because if you get those backwards, you're toast. All right, so this spot right here uses row 1 and column 1. This whole matrix is called the row matrix. You'll only always pick rows out of that one. All right? This one's the column matrix. You'll only always do columns from that one. So when they ask for row 1, would you please take a highlighter? I think you guys have that on your iPad, don't you? And my highlighter's not working right now. This is weird. Huh? I wonder if everything's frozen or just, no, it looks like it's still recording. All right, this I'll have to circle because my highlighter won't work. Oh, there it popped up. Yay. Okay, I'm highlighting row 1. That's row 1. And now in the column matrix, I'm highlighting column 1. Now in the United States, we read from left to right and from up to down. And you may assume that everybody does that. Not true. There are other cultures that read completely backwards of the way we do. They start on the right side of the page and go to the left. Anybody know a language that does that? Yes. Arabic. Any others? Is that the one you're going to say? Okay. I think Hebrew, I think I've heard, goes that way too. And I think I know the Chinese, traditional Chinese. And I think they've switched it in current Chinese. But anyway, okay. So we read from left to right. So which of these two is the first one that you come to? Well, that one would be. To me, 2 is before the 1 because I read from left to right. So it's really easy if you are in the United States to get this right, where we always pick the first one here. Well, which of these two is the first one? 1. And so therefore, the 2 and the 1 go together, and we multiply them, because this is, after all, a multiply problem. 2 times 1 is 2, and then we take this one and this one, and we multiply those. So negative 3 times 1, which is negative 3. So now I have 2 and negative 3. What's your gut feeling on what to do with those two numbers, the 2 and the negative 3? You add them at the end. You're correct. And you get negative 1. And that's that element of the matrix. Anybody already have that before I wrote it? Raise your hand if you had that already. All right, a few of you are a little ahead of the game. That's awesome. All right, now I'd like you to move the row in the matrix highlighting. Hold on just a second here. Because we're not doing this one anymore. I'm going to get these cleaned up. And that doesn't have to be important anymore, or that. Okay, now go over and do row 1. And column 2. And do the same thing for all the other 3 spots. You're multiplying your first matrix all the way out. This, by the way, is considered in the echelon of some of the hardest stuff on the ACT. It's really not that hard, but it's like one of those things that they, in their list, they rank order how hard all the skills are on the ACT. In the ACT math section, this, in that category that it's in, is considered one of the highest level questions. Because it is weird. Not that many kids that even know how to multiply matrices. On the ACT, I bet you if you take 100 kids, 50 of them have probably never multiplied a matrix in their life. And then probably another 25 of the remaining 100 only saw it maybe once, and then that was it. So a lot of kids can't do this on the ACT. It's not that hard, really. Okay, so let's see if you did it right. That goes with that. 2 times 0 makes 0. 1 times 8 makes 8. You add the 0 plus the 8, and you get an 8. Raise your hand if you had an 8 right there. Awesome. All right, Dice of Destiny. Who should I call on next? Red's the row. Row 1, person 3. It's you. What did you get? Or tell me how to get this guy, R2C1. That is correct. Hold on just a second. I am going to fix something here. There, There. Okay, 4, 7 goes with 1, 1, -3. Yup. There. And then, tell me what to do. Yup. That's 4 and 21. And what do you do to them? -17. Who actually had -17 in that spot? All right. And Dice of Destiny, who's going to do the last one for me? Row 5, second person. It's you. Yep. So that's row what? Row 2. And in the next matrix, it's column 2. Excellent. Hold on. To-do. Okay. Now what? 4 times 0 makes 0. 7 times 8 makes 56. And then you add them and you get a total of? Final answer? A little louder. What's the answer? 56. Okay. Raise your hand if you had 56. Okay, good. It was just 0 plus the 56 makes 56. Okay. All right. That's how you multiply matrices. That's not that bad, is it? All right. Now, I know they can be weird, like that one I gave you before. That by this. Would you please multiply these together? Whoa. And see what you get. Pause for a second. Let me give this a try. All right, so you should have realized this only had one row, 4 columns. This has 1 column and 4 rows. And so since these matched, the answer would be a 1 by 1. Did you just get one element? You should have. The one precious Easter egg. Do you have to have an Easter egg in there? No. I just do that because sometimes it's hard to tell if it, let's say it's a 4 by 3 matrix. Sometimes kids will write it the wrong way, and then you get the whole thing wrong. And if you know that your Easter eggs are all set up right with your, 4 rows and 3 columns, anyway. So you don't have to have a little egg in there, but you just need one number. And that goes with that and makes 0 because you multiply them. That makes 0. That makes 3. That makes -2. And you add 3 and -2, and you should have gotten 1. Raise your hand if you had that. Awesome. Okay. Now you can multiply matrices. That's all there is to it. Now some other little like fine points, things that make it more complicated. Do you get if I reverse these two, I will get a different answer? And it does not mean that it'll automatically just be the opposite of this answer. That'd be great. That'd be logical if it isn't the case. I would like you to quickly reverse these two by moving them back the other way, reversing them, and see what you get then. You'll get a completely different answer. I'm going to pause for a second while we reverse the positions of A and B and do B times A. Okay, so you reverse them like this, then you realize that you got a 4 by 1 and a 1 by 4. And I hope you took a moment to just go like this and realize, oh, I have a 4 by 4 matrix at the end of this one. What? You thought there was only one answer? Nope. It's a 4 by 4 matrix. That's where my Easter eggs come in. Get how that all of a sudden became a really intense problem? So what's this spot? It's row 1, column 1. Here's row 1. I'm going to go across even though the row only has 1 in it. And column 1, even though it only has 1 thing in it. And I multiply, then I'm going to get 0. But that's kind of boring because anything times 0 is just 0. Let's go to a random spot. Let's pick that spot. That spot would be row 2, column 3. Row 2, column 3. Goes right in there. Row 2 would be that. Wait. Row 2, column 3. Oh, blast it, I got another 0. But at least I knew the answer. 0 times the 3 made 0. How many of you got 0 for that spot? Okay, awesome. All right, let's do one that actually has an answer. If I look ahead, I just want to make sure I use row 3 or 4, because otherwise I'll just get zeros. Okay, so this is where row 3 would be. So I'm going to pick that one now. That's going to be row 3, column 2. So here's row 3 and column 2. And that's going to be 1 times 1, which makes 1 right there. Okay, I think you got the idea. Now, other stuff you have to know about matrices. Number 1, you could put them on a calculator. A calculator can do these. All right, so we're going to go back a notch. If you still have this page of your notes, do you remember doing this one? We're going to let the calculator do it, and it'll get the same answer, and I'll show you how that works. Everybody grab your graphing calculator. If you want to borrow one, now would be the time to bring me some collateral like your cell phone, your keys, not a library book, because I can't tell whose that is. Pausing. Okay, so here's a quick lesson on how to put these in the calculator. First of all, look for the matrix key. Do you see it in blue right here? See where I'm pointing? Left side of the calculator above the x to the -1 right there. All right, so we're going to go there. I'll move this around so that we can not have that in the way. Everybody hit the matrix, which is second, right there. Now, be careful in here. First of all, we want to do edit first. So go over to edit before you do anything else, so you'll just have to, go back and do this over again. You've got to edit matrix A. It says it's a 1 by 1. That's just the default. Do you think we actually have a 1 by 1 for our matrix A? No, we have a 2 by 2. So first you do is enter that as a 2 by 2, enter. Then we type them in, and they will go from left to right, just like you're reading a book. 2, 1, and then 4, 7. 2, 1, 4, 7. All right, you need to be following me on this. Do you not have a calculator? Okay, come on up, hurry up. You got to have the experience, or on the test you'll be lost. Thank you. Anybody else need a calculator? Come on up. Do you have a spare calculator? No, I actually do. Okay, that's great, but I still need her to have a calculator. So come on up. Get this over with. All right, so we've got our 2 by 2 matrix in. Matrix A is done, and this is weird. We just quit. And now, it'll remember matrix A. What do you think we're going to go do now? Okay, so go back into matrix, and then edit. Matrix B. Oh, at least it remembered that A was a 2 by 2. And I hit enter on the B matrix, and it asks, oh, and that's also a 2 by 2. And then I just type in the numbers. 1, 0, just like you're reading a book. -3. Make sure you use the negative key and not a minus. Every year there's some kid who does a minus, and then the matrix fails. You have to use the negative key. -3 and 8. Now, usually by this point, there's somebody who's gotten lost. Please ask the kid next to you. I don't want you to just sit there the whole time. Would you please show them your matrix screen like this? Second matrix. And it should say 2 by 2 and 2 by 2. Otherwise, they haven't got it right, and you should help them. Anybody having issues? Did you compare yet with the girl next to you? Compare. Just make sure that you both have the same thing. And if not, help. Okay. So now how do we actually multiply the two matrices together? All right. Yeah, quit again. And now I need a nice blank screen where I can drop an A and a B. Now, if you just type A, it's a really common mistake. People think they just have to put in an A right now. But A, like this, is different than a matrix A, which looks like that. So if you just type in the alpha A, it's not going to work. So how do I get matrix A to come back again? I go back to the matrix menu and I hit enter on that. Notice I didn't hit edit this time. I just hit enter. There's matrix A. Now what do I want to do? Times. You're multiplying. Matrix B. Just enter. And there it is, A times B. And you hit enter, and it actually does it. Is that the same answer we got? Negative 1, 8, negative 17, 56? Yes, it is. Do you get that this is something that's easy to forget? Like 1 year from now, you're taking the ACT. Or 2 years from now, you're taking the ACT. Do you get this is the kind of thing that's easy to forget? But if you just watch like a 2-minute review video, it'd be like, oh yeah, I remember this. That's one of the keys to doing good ACT review. See, kids that have never learned enough math, it's really hard for them to learn 200 things. But kids who've learned all the math, a lot of times forget little pieces. And if with a 2-minute reminder, you can remind them, but you can't teach somebody matrices from ground zero to multiplying matrices in like 5 minutes. There's no way. But if 2 years from now, you're just about to take the ACT again, and you've forgotten this stuff, a 2-minute review video would help. It's one of the reasons I made that 2-minute teacher thing. It's one of the reasons I got that website, Algebra Ninja. It's got all those little review videos, so you can just remind yourself a little bit. Because a lot of really smart kids are in like AP Calculus, and they've forgotten little putsy stuff like this. Okay, so now, do you remember me saying that B times A would be different? Would you please do B times A, and let's see how different it is. That is quite different. Completely different answers. So that's one thing that's important to know is that you can't just reverse matrices. They're going to give you completely different answers. Okay, next. The concept, remember we're doing a lot today because I'm covering pretty much everything. The concept of an inverse. If I have 8a equals 30, how do you get that a off of there? Well, you can say divide by 8, but couldn't you multiply by its inverse? And this is tricky because there's inverse and there's reciprocal. And there's additive inverse and there's multiplicative inverse. Whoa. Okay, so I'm just going to show you like this. Would you agree that if I multiplied by 1 over 8, which is the multiplicative inverse, do you get that this would solve my problem and I'd have a alone? Does that make sense? Do you get that it involved an inverse? Okay. Then here is a typical at the end of this unit question. Remember, I'm trying to teach you everything that you'd have to know for the test today, and I might not get through everything, but I'm going to be close. Do you get that if I have let's say I had that. Do you get that you could use like normal solving to solve this system of equations? In case you forgot, you could solve for x. And do you get 8 minus 4y could then go in here and I could solve that system? Does that ring a bell? It's called solving by substitution. All right, that's a way that would work. But when you have really big problems like this, that is a pain to do. And the cool thing is that matrices can solve this. I bet you will catch on quick. Where do you think I got those numbers? Do you get that those are the numbers from the problem without the letters? Those are called the coefficients. Then I'm going to say times. Do you get those are the variables that I'm trying to solve for, and take a wild guess what I'm going to put in there. And now I'm going to call this matrix A, and I'm going to call this matrix B. How do you think I'm going to get the A in matrix off of here so that I have the variable solved and all alone? How do you think I'm going to get rid of the A matrix? The inverse of A. Remember me just doing that a second ago with the 8? I used the inverse. Then I'd put the inverse of A here. And if I do it to this side of the equation, do you get I'd need to do it A to the negative 1 is the inverse of A on that side of the equation? And last thought, do you remember that the order you multiply them in totally matters? And you have to do inverse of A times B. If you do it backwards, that wouldn't be following that rule that having it in front versus having it at the end makes a difference. And then what do these do? They cancel each other, so that's gone. And all I have to do is do the inverse of A times it by B. Do you get a calculator could do that? What was the A matrix again? That's the A matrix. That's the B matrix. And you'd have to do inverse of A times B. All right, now, last thought. To get the inverse, if you can stay with me for 3 more minutes, I will have covered the whole chapter. And we're going to have several days then to practice and make it work. And this has been working for me, for you guys. For the last couple of tests, you've been rocking these tests. So let's see if we can power through. Just about 3 more minutes. To get an inverse, everybody write this one down. 1, 4, 3, negative 2. If I need to do the inverse of this, yes, a calculator can do it. But no, you can't trust that you're always going to have the calculator to do it. Because sometimes they throw in a variable, and all it takes is to make that a 4A, and now your calculator can't do it for you anymore. So you have to know the process. All right, so how do I find the inverse of this matrix? First of all, I need to know what a determinant is. DET, the determinant of this. I'm going to show you how I get it, and let's see if anybody can figure it out. The determinant of this matrix is negative 14. Do you get what I just did? I can see some people have figured it out. It's kind of like cross multiplying. It was that times that minus this times this. Okay, why do I need this determinant thing? Because here's what you do to find an inverse. You're going to first find its determinant. And then you go 1 over the determinant times the matrix, except I have to take this matrix, and instead of doing 1, 4, 3, and negative 2, I switch these 2 places, and I change these 2 to the opposite sign of what they are. Whoa, that's intense. These 2 switch places, and these 2 become the opposite of what they are. That's how you find an inverse. Now, I've taught you everything. I know some of that went over your head. But I also know some of you could take the test tomorrow and get a B on it without any more instruction. So now, we just have to polish it up, and then you get an A on it. All right, so let's see how much of that actually stuck. 0, 1, 4, 3. Would you please find the DET, the determinant? That was kind of that cross multiply thing. What's 3 times 0? 3. What is 4 times 1? 4. And then I subtract them. 3 minus 4 makes negative 1. Raise your hand if you had negative 1. No. Did I screw it up? What'd I do? Oh, thank you. Oh my gosh. What is 3 times 0? 0. What is 4 times 1? 4. And then I subtract them. I was wondering why nobody was answering, and then I just, oh, okay, fine. All right, 0 minus 4 is negative 4. How many of you got negative 4 for your answer? Okay, good. Now, can you believe that there's a thing on your calculator would do this? Because there is. It'd be under matrix, and let's just see where it would be. It'd be under matrix and under math. Matrix, math. Oh, I just cleared it. Rats. Matrix, math. See that top one, DET? That means determinant of. Determinant of which matrix do you want, Mr. Server? I want Mr. A. There it is. Determinant of A, enter. The determinant of the A matrix was 10. One last thought. What the heck why do I care? What's the determinant of this? It's negative 4. If I want the inverse, who's got amazing enough memory that they think they could do this? What I did a second ago. What do you think you do?
So you take 1 over,
which was? Very good. And then?
the 0 and 3 flip, so from 3 and 0. Then before the
I'm so proud right now. And you multiply that out, and that's it. And you got the matrix for the inverse, all by yourself without the calculator. So 1/4 times the 3 makes negative 3/4. 1/4 times the negative 1 makes positive 1/4. 1/4 times the 4 makes, and then they're negative, makes it positive 1. And anything times 0 is 0. Boom, there's the inverse, and you've learned everything for this chapter. Okay. That's a lot, and I know you didn't get it all. But you know what? At least the cool part is, for tonight's homework, all you got to do is multiply them, which is going to feel like Easy Street. Okay? So let's go find that. I'll tell you which ones to skip. And yes, I'm aware that it currently still says 4-11, like we should have done this yesterday, but, you know, we were having a snow day, so I haven't changed it yet. If you go into the homework, sorry, it's taking a second, but Schoology's slow today, and then I click on this one. And here are the ones that you can skip. We're going to do 1 and 2 and 3. Then you're going to skip number 4 because frankly it's too easy and too normal. Next one we're going to skip is number 8. And then let me think. Number 11's a skip. Number 12 is a skip. It's just so easy. If you really want to practice, go ahead. I don't think you need to, as long as you did your homework yesterday. So then we'll just do this one. Why this one? Because it throws in this. I've seen this on some ACTs as well, where they throw in multiplying and adding matrices at the same time. Just remember that you do all this multiply first. Everything gets multiplied by 3. Everything gets multiplied by 7. And then at the end, you can add them. Now, you can do it all in one big step if you want to. Like to find the first answer, like this Easter egg here. You could go 3 times 5 is 15 plus 7 times negative 5 and do it all in your head. 15 and negative 35 when added together make negative 20. So in this Easter egg, we'd put a negative 20. Okay. All right. So that gives you a reasonably sized assignment. Let's get started on it. Make sure you do number 1 right, because my daddy always said when you're started, you're halfway done. So let's get started. This is a 2x2 and a 2x2, so I know it's a 2x2. I'm not even going to take the work of writing that out. On this I would, though, just to clarify, because sometimes these don't work. You don't want to, like, not check in case they don't work. This, by the way, was 2 rows and 1 column, and this is 1 row and 2 columns. And, hey, it does work, and the answer is a 2x2, so you should take a second to do that. Sometimes on the ACT, I've seen it actually say which of these matrices can't be multiplied, just to see if you know that little test. And this one can be multiplied, and the answer would be a 2x2. So then I put Easter eggs in here, and that's row 1, column 1. So this is row 1, this is column 1, negative 30. Back to this one. That's row 1, column 1. Here's row 1. Here's column 1. Did you do 0 plus that's a positive 3. Sorry, I thought it was a negative 3. 0 plus 6 is 6 in the upper left-hand corner. Did you have a 6 there? Yes? Yes? Was there a 6 in the upper left-hand corner of the first problem? Okay, good. All right. And the rest of the time is yours.